Right, so our final topic on logs and exponents. Right, and today we're going to look at the inverse of logs and exponential functions. They are inverse functions of each other, and we're going to take one and make it into the other. Right, now when we look at logarithmic functions, when we change them and create their inverse, we just need to remember that for logarithmic functions, all log functions have a domain restriction for x, right? Because the value inside there has to be greater than 0, okay? Because our log laws are only defined for values greater than 0, okay? Unlike for exponentials, right? Exponentials can exist for all values of x. So let's do the first one. We have f of x equal to 2e to the minus 4x plus 3. And we want to find the inverse and then state its domain. So it's very cumbersome to keep writing f of x, and so what we do is we just say let y equal 2e to the minus 4x plus 3. It's just easier than writing f of x the whole time. Right, now from here, what we need to do is we need to remap, okay? So when we remap, what we're doing is we're swapping all the y values and creating x values, and all the x values become y values, okay? Because an inverse is a reflection about the y equal to x line. That's why we swap the values around. So we'll have x equal to 2e to the power of minus 4x plus 3. Oh, sorry, 4y, plus 3. Now, from here, we need to resolve for y, okay? Now, y at the moment is stuck up here as an exponent, right? And the only way to get it down is we're going to have to change to a logarithmic function at some point. But we need to isolate everything else on the other side. So I can isolate my base e to the minus 4y over here, and everything else, x minus 3 over 2, can go to the other side. Now, remembering how we change from exponential to log, identifying the parts, this is the base, here's the exponent, and this whole thing is the value. So when we write things as logs, we literally write a log, and remembering that logs with base e are just written as the natural log, right? So we have the natural log, and here we put the value, which is x minus 3 over 2, and on the other side we have minus 4y. And to solve for y, we can just divide through by minus 4, or we can multiply through by minus 1/4. So we have y equal to minus 1 over 4 times the natural log of x minus 3 over 2. Okay. Now, we weren't asked to find a function y equal to, we were asked to find the inverse, and so we can just change this y into the appropriate notation, and the notation for the inverse is f to the minus 1 x is equal to minus 1 over 4 times the natural log of x minus 3 over 2. Now, at this point, we would think we're done, but we're not actually. We need to remember that this thing inside here needs to have a domain restriction. It has to be positive. And so we can create a quick inequality, and we can say x minus 3 over 2 needs to be greater than 0, okay, for the log to be defined. And solving this, we'll see that x has to be greater than, not 0, greater than 3. Okay, and so we can state this as a domain x must be greater than 3. Okay, now let's take our second example. Here we have f of x equal to 3 times the natural log of 2x minus 4. And we want to change this into its inverse. Okay, so the same thing as before. To rewrite f of x every time is cumbersome, so we'll just say let y equal 3 times the natural log of 2x minus 4. And once again, we want to remap our x and our y values, so we're going to switch them around. So everything that was x is y, and everything that was y is x. So here we have x equal to 3 times the natural log of 2y minus 4. Now the variable I'm trying to solve for this time is stuck inside here. It is the value of a log function, Right now, if I change that into exponential form, it becomes the subject of the formula. So what we'll do is we'll isolate everything that has nothing to do with the log on one side. So that means we'll push the 3 over to the other side, equal to the natural log of 2y minus 4. Now remember, the natural log is just log to base e. So when we change to exponential form, we'll change it to base e. Okay, this is the exponent, and this is the value. Okay, so the exponent goes on top of the base, and this is equal to the value, which is 2y minus 4. Okay, almost done. We can solve for y, so we can see that y is going to become e to the power of x over 3 plus 4 all over 2. And we can simplify that further by dividing that 2 into the 4 as well, right? And to continue, we can also remember that we weren't asked to solve for y, we were asked to solve for the inverse, and the inverse is f to the minus 1 x is equal to 1/2 e to the power of x over 3 plus 2. Okay, and unlike the log function, there is no domain restriction for this function because an exponential exists for all values of x, and the way we state that is we just say x is an element of all the real numbers, okay, meaning there's no domain restriction.